In this section, we discuss the phenomenon of the polarization of light when it is reflected and refracted from a surface. For incident angles other than 0 degrees, unpolarized light becomes partially polarized in reflecting from a non-metallic surface, such as water. To demonstrate this fact, rotate a pair of Polaroid sunglasses in the sunlight reflected from a lake. You will see that the light intensity transmitted through the glasses is a minimum when the glasses are oriented as they are normally worn. Since the transmission axis of the glasses is aligned vertically, it follows that the light reflected from the lake is partially polarized in the horizontal direction. There is one special angle of incidence at which the reflected light is completely polarized parallel to the surface, the refracted ray being only partially polarized. This angle is called the Brewster angle, theta b. The value of theta b is given by Brewster's law, which is given by tangent of theta b equals n2 divided by n1, where n1 and n2 are, respectively, the refractive indices of the materials in which the incident and refracted rays propagate. This relation is named after David Brewster, who discovered it in the 1800s. Note that the reflected and refracted rays are perpendicular to each other when light strikes the surface at the Brewster angle. This can be proven by applying Snell's law and assuming that the Brewster condition is satisfied. To illustrate that reflected light is at least partially polarized, consider the light that reflects from the back window of a car. If we look through a polarizing sheet, which mimics the effect of polarized sunglasses, we see the effect clearly. When the polarizer is oriented with the transmission axis parallel to the polarization of the reflected light, we cannot see the left headrest because of the glare. Since the glare is mostly reflected light, it should be polarized mostly in the horizontal direction. Therefore, when the polarizer is oriented with its transmission axis vertical, perpendicular to the polarization of the reflected light, the glare should be filtered out, and we can see through the window and get a clearer view of the left headrest. Polarized sunglasses work well when there's a lot of scattered light, such as light scattered from water or snow, or from wet roads.